8.4 redundant systems. All right, so in this part, let's look at the redundancy in system. The reason is very simple. We want to make this whole system more dependable, reliable. By adding redundancy, we can get that. Although you need to pay a lot more, but to reduce the service interruption, if you put all the factors there, actually it is a good solution, good way to do it. All right, so let's look at the redundancy. The primary way to cope with failure is redundancy. So you can imagine it's pretty simple. One device fails, then you have backup. And think about that. Last time we learned that single points of failure, right? So look at that part, single points of failure. By adding redundancy, you can reduce and even remove single points of failure. All right, so let's look at this picture. Primary server, secondary server, redundancy. If any failure occurs, you can quickly move to the secondary server and provide the same service. For the database part, also, you have the mirrored data, redundancy, different copies of the same data. So in that way, you can see if one location, the data gets some problem, then you have other copies in different locations. Still provide the normal services. All right. Then, when we talk about redundancies, here there are two different meanings. The first time, in time meaning. We add redundancy in time. Here. When you do some operation and you notice some error in that operation, then we just repeat the same operation. Because when we do the operation, there could be some problem occur that caused the error. Then in time, we repeat it another time, and we hope to fix the problem. So that's the in time meaning. But the second one, more popular. So usually most of the time people using this meaning, in resources. We add redundancy in resources. Have other components to take over from the one that failed. You can see this case, or in resources. This is the most common way so that people add redundancy to improve the reliability, dependability. All right. Then, another thing, because when the system has some problem, then we need to call the service provider to fix the system, right? So to repair the system. All right. So here we consider a redundant or non-redundant. Redundant or non-redundant. So sooner or later, we need to repair the system. In that situation here, we make this assumption on a repaired system. So what's that? once the component is replaced and the system fully repaired, the dependability of the system is assumed to be as good as new. Yeah, that's assumption. Yeah, so you fix the problem, you replace some bad part, yeah, and make it work again, then we assume we have a new system, yeah, as good as a new one. Yeah, so that's assumption. Yeah. The reason is we want to make the whole thing as simple as possible, right? Yeah. So, yeah. All right. Next, actually, before I show you the new example, I want to say a few words, related to our textbook. Now, we have a redundant system, right? Redundant system. And there are one example in our textbook, doing things in a redundant system. Actually, that question, it's very hard to understand. The question looks not very complicated, only half page, but very hard to understand because it relies on some special assumption, very special assumption. So, for that reason, I like to avoid that part. Because for me, it is hard to explain well, why we do in that way. For that reason, in my questions, I will avoid to assign you any questions related to redundant system. Yes. The question I will give you for this part, this topic, we only consider the non-redundant system because in that situation, it is very easy to do the calculation. Redundant system, you need to base on some special model, some special statistics model. Then even under that, when you set up equations, it is very difficult. All right. So that's the comments. Then we look at our first example in this topic. It is a very simple example. Later, I may add a little harder questions on this topic. All right. Question. We have a single processor with a failures in time, FIT, of 1,000. 1,000. All right. But here, the background you need to use. So this 1,000 per billion hours. Remember that. Because we changed to that. So we get this 1,000 failures number. All right. If the availability of the system is 99.999%, how many hours does it take to get the system running again when there is a failure? So you get a failure. Then, you need some time to fix it, to get it to run again. So what's that concept? Okay. You have a failure, right? Starting from a failure, then you repair it. Okay. All right. Mean time to repair, right? Is that mean time to repair concept? So you want to calculate that mean time to repair concept. MTTR. So that's our goal. All right. So we have some formulas, right? Availability formula. So look at this. Availability is 99.999%. So then FIT related to what number? Mean time to failure, right? And FIT related to mean time to failure. Yeah. So then availability formula, you can calculate this number. Yeah. All right, so let's do it. Yeah. Very simple. When we start, we know FIT 1,000 per billion hours. Okay, yeah. So then when we do the calculation, we need to do conversion first, right? When we calculate MTTF, we need to do appropriate conversion first. Yeah. Because the formula is this, but this, we should not use the per billion hour, we should use the per hour. Yeah, so this one, you know, when you do the reciprocal like this, you should use the per hour unit. Okay, yeah. Number of failures per hour. All right. Yeah. Let's do the conversion. Yeah. All right. Yeah. How to do the conversion? Divided by 1 billion. 1,000 divided 1 billion. So that's the conversion. Yeah. 10 to the negative 6th power. Yeah. All right. So we have this number. So then now you do the reciprocal, so you can get MTTF 1 million hours. MTTF, that's 1 million hours. So you have this number. Next, using the availability formula, you can find MTTR. All right. So let's continue. Availability formula first. Module availability, this MTTF over MTTF plus MTTR. MTTR unknown, right? Unknown. But both known, availability also known. We can solve this equation for MTTR easily, right? Yeah. So let's do the calculation. 99.99% equals 1 million over 1 million plus MTTR. So then you calculate MTTR, you know, just do some simple math. Yeah, you get a final answer. 10 hours, approximately 10 hours. The final answer. Now you can imagine. So what's the meaning of this 10 hours? Okay. The meantime, so when you get a failure, you need to repair the system. How long do you need to repair the system? On average, 10 hours. That's pretty reasonable, right? Yeah, that's pretty reasonable. You know, matching the real world situation. All right, so that's the last video, and we finished the whole part A.